Okay, hello everyone. Today we are going to talk about slope-intercept form. So the first thing with slope-intercept form is to start to consider what points may lie on a specific linear equation, or graph. So here, the first question is, does this point 2, 0, is this on this line? So I'm going to go over to, remember that this is my x, this is my y, this is my x-axis, this is my y-axis. So they want to know when x is 2 and y is 0 right here. That does appear to be on the line, so I would say yes. I'm going to skip to this one over here, -3. So I'm going to go to -3 on my x, and then -3 on my y. That's right here. And that does not appear to be on the line, it just misses it. 5, 1.5, so I go over to 5 and I go up 1.5. That does appear to be on my line. 8, 3. Okay, so 8, 3 goes off my axis. It goes out of my picture. I could start to imagine this. I could also just try to plug it in an equation if I had the equation. But the point is that even though the points 6, 2 and 8, 3, because 6, 2 right here as well, even though those points are not shown in this picture, I can still be confident that they're on the line. I can still figure that out. And then over here, I have -1, 0. That's right here. That is not on the line. So these two, I can figure out if they are on the line. They are actually both indeed on the line. If you look at our slope here, we've talked about how to find slope. My rise over run is up 1. So my rise is 1. My run is 2. So I'm going up 1 over 2. So if I go from here, up 1 over 2, that's going to get me to 7. And then this would be about 2.5. So that means if I'm in between there, that means 6 would fall on 2. If I go up from 7, 2.5, up 1, that would be to 8. If I go up 1, that would be to another 0.5 over 1. That would be 8, 3. Okay, so you can kind of imagine it. You could also go ahead and just extend your graph. I kind of already wrote x-axis here, so that kind of defeats the purpose. But you could also go ahead and extend your graph if you're more of a visual person. So I have 6, 7, 8. So this is going here. Okay. So you can kind of see the pattern. All right. The real goal for this lesson is I want to be able to ask you something like, is 128, 63, is that point on the line above? Obviously, we can't answer that right now. Excuse me. A key reason why we can't answer that is because we don't even have an equation. So let's look at a situation where we do have an equation. So graph this linear equation here by making a table. When it comes to an equation, we have an input and we have an output. Oops, wrong spot. Okay, our x is our input, our y is our output. So if I plug in a -1 for x, if I'm inputting -1 for x, I want to be able to tell you what am I going to get here. So the way I would figure that out is I would plug in that -1 for x in my equation. So instead of writing an x, I'm going to write a -1. So that gives me -2 times -1 is +2, plus 3 is 5. So that gives me a -1, 5. That is a point on my line. So I just solved for y. Okay. So I can go to my graph now and go -1, 5. That is a point. I could also do it with 0. I'm just plugging in to this original equation this value of x in for x. That gives me 0 plus 3, which is 3. So 0, 3 is a point on my line. It's also important that whenever x is 0, remember that this is also my y-intercept. We mentioned it a little bit in class recently, but whenever your x is 0, whatever your y is a y-intercept. That's where our graph crosses the y-axis, which you can see here. I'm going to keep going with this chart. I'm now going to plug in a 1. I get -2 plus 3, which is 1. That means 1, 1 is a point on my graph. And then lastly, I'm going to plug in my 2. -4 plus 3 is -1. So 2, -1 is a point on my graph. Now I can connect these dots. You should notice here that we have a negative slope. So graphing linear equations with tables takes a long time. Okay, what we notice about the equation is that its slope is, so if we look at this, it's going down 2 over 1, so -2 over 1, so its slope is -2. And it also crosses the y-axis at 3. Okay, so this is the y-axis. Wherever this line crosses on we want that y value. So what this tells us is that there is a faster way to graph linear equations. The fastest way to graph a linear equation is in slope-intercept form, which is y equals mx plus b. Our m is our slope. Our b is our y-intercept, which is where it crosses the y-axis. I'm going to flip my page now. So if I'm looking at this, the first thing I want to be able to do is identify what's the slope, what's the y-intercept. The slope here would be 3. Okay, remember, it's this form, y equals mx plus b. Okay, my y-intercept would be the 4. My slope here would be -2 over 3. My y-intercept would be -5. There's no value in front of this x, which is where my m should be, so that's a 1. Whenever there's nothing there, it's a 1. So my slope is 1, my y-intercept is 6. And this one has no y-intercept, okay, which means it's 0. There's nothing there, it's 0. There's also nothing in front of the x, which once again makes that a 1. Okay. Remember that if this was a 0 in front of the x wouldn't be there, kind of like the y-intercept. It's not there, which is why we know it's 0. Now let's go ahead and graph some linear equations using our slope-intercept form. The first thing we're always going to do is plot the y-intercept, and then we are going to use the slope to plot more points. And then lastly, we'll draw the line. So here's a quick example here. If I have y equals 3x minus 1, first I'm going to identify that my slope is 3 and my y-intercept is -1. So I'm going to start by plotting the y-intercept. So I'm going to go to my y-axis and I'm going to go to -1 and put a dot. Now I'm going to use my slope. 3 is the same thing as up 3 over 1. So I'm going to go rise 3, run 1. Rise 3, run 1. I have 3 points now, so I could just graph my line. I like to go as far as I can on my graph. If I want to go in the opposite direction, I just have to go backwards. So I go down 3, left 1. Okay, and I don't have a ruler, so this might be a little crooked. But there's my line. If you're not going to do all the dots on your line, it is best to use a ruler so you make sure you don't make any errors. So let's do some more of this. So let's quickly review slope, and then we will graph some more equations. So 4/5 means you are going up 4, right 5, if that's the slope. If your slope is 6, it means you're going up 6, right 1. Okay, because essentially that's 6 over 1. If you have a -3, you're going down 3, right 1. Because it's essentially -3 over 1. -2 over 3 means you're going down 2, right 3. It's essentially -2 divided by a +3. So let's go ahead and graph some of these equations. I'm just going to do a few of them with you, as my videos can only be so long. So the first thing is the y-intercept is 1, so I'm going to put a dot on 1. And then my slope is 2, which is 2 over 1. So I'm going to go up 2 over 1, up 2 over 1. If I want to go backwards, I'm going to go down 2, left 1, down 2, left 1, down 2, left 1. And then I can make my line. Here I have 1/2 x minus 3, so my y-intercept is -3. And then my slope is 1 over 2, so that means up 1 over 2, up 1 over 2, up 1 over 2. If I want to go backwards, I go down 1, left 2, down 1, left 2. Okay, I'm going to move to this one over here. This one has no y-intercept, so that means I start at 0. I still have to put a dot there. And my slope is 3 over 2, so I'm going to go up 3 over 2. Up 3 over 2. If I go backwards, I go down 3, left 2. Okay, I'm going to scoot back over here. I have -5x plus 2, so this is my y-intercept is 2. I'm going to go, if I have -5, that's essentially -5 over 1. So I'm going to go down 5 over 1. I can't do that again because -5, 5 is a big number, so I'm just going to connect my dots. You only need 2 dots to make a line. 2 points to make a line. This one, my y-intercept is -2. And my slope is -3 over 4. So that means I'm going to go down 3 over 4. Opposite way would be up 3, left 4. And then lastly, I'm going to do this one. This is just a 1 in front of that x and a 0 here. We have no y-intercept, so I'm going to put a dot on 0. And then my slope is just 1, or 1 over 1. So I'm just going to up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. If I wanted to go backwards, I'd go down 1, left 1, down 1, left 1. Okay. I'm going to skip these two just for sake of time. Okay. But those were a lot of examples. Now, the last page here is asking you to now write your own equations for these lines. So you just have to identify what is the y-intercept, okay, and what is the slope. So first off, I'm going to do the y-intercept. So the y-intercept of this one is a +2. The y-intercept of this one is a -1. The y-intercept of this one, and I'm just going to also put a dot here, is -2. The y-intercept of this one is +4. This one is at 0, so there's no y-intercept. I can put that just if I want to, but you also don't need to. And then this one is at -3. Now we've got to identify the slopes. We've got the y-intercepts. We've got to identify the slopes. So make one more point on your line, and then we're going to count how much are we rising and running. So I'm rising 1 over 3. So I'm going up 1 over 3. So that means my slope is 1/3. And I always have to put an x next to my slope. So my equation is 1/3 x plus 2 because I need it in this y equals mx plus b form. Over here, my y-intercept's -1. Now, I have a negative slope here. Remember, positive slope goes up from left to right. Negative slope goes down. So I know my slope is negative. So I'm going to go ahead and put a negative value there. Okay. And I'm going down 1. And this appears to be my next most clear point. So I'm going down 2 over 3. So -2 over 3. And I always need an x next to my slope. This one is a positive slope. My next definitive point is here. Appears I'm going up 2, 5 over 1. So my slope is 5. And I always need an x next to my slope. If you put it as 5 over 1, that's okay. But remember to simplify. This one is definitely a negative slope. It's going downhill. Same with this one. So I'm going to go ahead and put a negative in both of those. And my next definitive point is very close. So I'm going down 1 over 1. So that's just -x, or you can put a 1 here if you wanted to. So my slope is just -1. So you could put -1x plus 4, or you could put -x plus 4. This one here, I'm at 0. I have no y-intercept. And this is my next definitive point. I'm going down 2 over 1. So my slope is -2, and I need that x next to it. You could write it as -2x plus 0, or you could just write it as -2x because there is no y-intercept. Lastly here, my y-intercept was -3. My next definitive points are very close, so I go up 1 over 1. So that means my slope is just 1. Make sure I have an x next to my slope. We could also write that as y equals x minus 3. We don't need that 1 in front, but if it helps you, you're welcome to put it there. Okay? For the sake of time, I think I'm going to skip this and we'll maybe return to it another time. All right. Hope this helps. Please let me know if you guys need any help further than this. Please reach out if you're struggling. Have a great day.